In my conversations with various teachers, one of the concepts that several teachers have said to me is quite difficult to explain and teach are logic gates. And following another conversation with another teacher last night who said he was trying to make logic gates out of microbits, I thought I'd have a go and see if that's possible. So what we've got here is I've made a half adder. I've got two microbits that are inputs, so these have got 0 and 0, so they're basically switches and you can turn them on or off. I've got an XOR, an exclusive OR gate, so it's got two inputs and it will show the output depending on what the input is. I've got another logic gate here. This is an AND gate. It's got two inputs. Both of them have to be on to get any output from it, and they're wired together to two display microbits. So these show 0 or 1 depending on whether they've got an input coming in. So they've got a single input and will just show 0 or 1. They're all wired together to form a half adder. So I'm going to add two binary numbers together here, and the sum and the carry digit is going to come from the outside. So what happens, I've got input A and B. If I turn input A on, so turn that, you've got a 1 on there, you can see one of the inputs has lit up on the exclusive OR gate and the output has lit up as well. So that means that exclusive OR will give an output if one input or the other, but not both, are lit. If I turn input B on as well, you see it's two inputs going into the exclusive OR, but no output. I'll turn input B off again and we'll just follow that through. So input A comes into the exclusive OR and we can see it's coming out of the sum. We've got 1 as the sum and we've got no carry digit, and we've got one input going into my AND gate, but nothing coming out because there's only one input. What happens now, we'll zoom out a little bit, try to, if I then add another digit. So I've got 1 plus 0 is binary 1, that's the sum. If I turn my input A off and I now put input B on, I'm doing 0 plus 1. And we should see the same result. We've got 1 as the sum and 0 as the carry. And the exclusive OR has got one input, so it's giving an output, and that's where the sum comes from. And there's nothing getting through the AND gate, so there's no carry. If I now, instead of adding 1, we've done 1 plus 0, we've now done 0 plus 1. I'm going to add 1 plus 1. So 1 plus 1, see how the logic gates change. I've now got two inputs going into the exclusive OR gate. That means nothing comes out. And my result now has changed. My sum is 0, but I've got a carry digit. So if you arrange the microbits in, I can't do this with one hand, in that order, I have made 1 0 in binary by adding 1 and 1 together. It's a bit messy, these need nailing down in some way, but it does work. And it's just a few blocks of code in order to code a logic gate or a display or a switch with each microbit. So you can do quite a nice half adder just using 6 microbits.